Yeah, thank you very much. Today we'll discuss about the data collection and in its interpretation in hydrogeology. To Before beginning, uh, can you interpret this image and how to control those? No, no. If they have to respond,
If they ask the question,
Yeah.
I will ask.
so this question from online participant also. Can you interpret this image? As you know, groundwater is hidden resource. Indirectly, we have to infer. So a lot of surfacial feature are there, some geological feature are there. Those help us to understand the groundwater occurrence. So this is related to groundwater occurrence. So can you interpret this image? Anyone? Offline or online participant? Can you interpret this image? You know, nowadays in school, this kind of questions are there. This kind of questions are very common. So can you interpret this image? What you are inferring from this image? Any online participant? Am I audible? Yes, offline participant. Can you interpret this image? Anything? Okay. Yeah. No, it's it's actually drainage map. It's a drainage map. So what difference you are getting? Okay, in drainage. If you see there, difference in drainage density are there. In upper portion, density are more, and lower portion, density are less. So why at least density difference are occurring here? What is the reason? Why? So if we are able to answer this kind of question, we can understand hydrogeology. Okay, because directly, indirectly, groundwater occurrence depend on the geology, geomorphology. So we have to understand these things. So what is the relationship between the drainage density and groundwater occurrence? Can online participant interpret this thing? There is no response. Okay. Yeah. So here, that drainage density or that depend on the porosity and permeability of the rock. If rocks are porous and permeable, you will find less drainage density. If rocks are impermeable, you will find more drainage. So upper portion rocks are impermeable. That's why runoff is more and formation of drainage are more, and that's why density are more there. And here in lower portion, rocks are porous and permeable. So maximum water is going as a infiltration. Then in this case, formation of drainage are less. So directly, indirectly, we can infer groundwater from the surfacial feature. And this is one example. So here we are talking about the groundwater. Let us understand what is groundwater. People consider all subsurface water is groundwater, but not true. That water which is present in the saturated zone, that water is known as groundwater. So here in this image, you can see this blue portion. Here all pores are filled with the water. So this is known as saturated zone, and whatever water which is present here, that is known as your groundwater. And upper portion of this saturated zone is known as the water table. And why groundwater is important? So why it is important? Our earth is known as a blue planet because we have abundant water. But in this, only 3% we have as a fresh water. 97% water is saline. And if this 3% we consider as a 100%, what do you find? In this 77% water is logged in glacier, which we cannot use for our drinking and irrigation purpose. And 1% water is present in as a surface water body. And in present condition, they are highly contaminated. We cannot use directly for our drinking purpose. And 11% we have that as a groundwater which is below 800 meter, which we cannot extract economically. And we are using 11% groundwater, which is available up to 800 meter. And if you see here, share of fresh water, is more as a groundwater. That's why groundwater use, groundwater is one of the most important source of water supply throughout the world. And that's why groundwater is important. And when it is important, so we must know where it occurs. It occurs in the pores of the rock. And these pores can be classified as a primary and secondary porosity. And primary porosity are those which develop during the formation of rock. Like in case of sedimentary rock, while they form, intergranular spaces are there. Those considered as a primary porosity. And once rock form, due to their disintegration, if pores are developed, those are considered as a secondary porosity. So for groundwater occurrence point of view, both are important. And if you go in rocky terrain, this kind of feature you'll find. These kind of feature, these give scope for the occurrence of groundwater. You don't think these occur only on the earth surface. If you see below earth surface, these also occur, and only because of these openings we get groundwater. And not only openings, there are other property also important for groundwater occurrence point of view, that is permeability. Porosity, we know porosity is void percent in the rock, and permeability is the property of rock material through which fluid can transmit. So both are important for groundwater occurrence, and these permeability are always related to interconnected pores. When pores are, those pores which are available within the rock, if they are interconnected, in that case only we have scope for the, permeability. Yes. So we must know the rocks, because groundwater occur in the rocks, and this is example of one rock. What is this? It's a granite. And what is rock? Rock are aggregate of the mineral. Like in this case, this rock is comprising quartz, feldspar, hornblende. So this is one example. And we have mainly three kind of rock. If groundwater occurrence point of view, if I ask in which rock will get groundwater, in which case will get groundwater, so your answer will be sedimentary. Why? Because in that case we have primary porosity. But if we find the, if we have igneous rock and metamorphic, in this case we have less chance to get groundwater. Why? Because primary porosity is negligible. Rarely we get. Okay, rarely we get. So always in case of sedimentary rock, we have scope to get groundwater. But it is not always true. Like here we are sitting over the Chhattisgarh supergroup rock. Here you will find, whatever that rocks occurring like limestone, sandstone, they're very hard and compact like igneous rock. So in that case also, due to secondary porosity, we get groundwater. Okay. So we must know the rock, their property, because groundwater occurrence depend upon their texture and structure. And you know that igneous rock, how igneous rocks are formed. Igneous rocks are formed due to cooling of lava or magma, and these can be formed on the earth surface and below earth surface. If I ask question, in case of, like we have those rock which are forming on the earth surface and some rock which are forming below earth surface, in which case we have a scope to get groundwater. Can anyone answer this? In which case we have a scope to get groundwater, either in case of those rock which are forming on the earth surface, volcanic rock, or in case of those intrusive rock like your hypervessel or plutonic. In which case we have a scope? Yeah. Am I audible, for online participant? Yeah. Okay. Yeah. In which case we have a scope? Intrusive or extrusive? It's a, logical question. So logically you have to answer, in which case? Intrusive. Why in case of intrusive, we have a scope to get groundwater? It's not, true. In case of extrusive, we have scope to get the groundwater. We have extrusive means what? Volcanic rock. In case of volcanic rock, there is a scope to form the vesicles. And vesicles means what? Voids. So when voids are there, we have a scope to get the, groundwater. But is there any possibility to form any vesicle in case of intrusive rock? No. Then how? So always, like, volcanic condition, we have a scope. But, you don't think we always, when volcanic rocks are there, you'll find the vesicles. But if vesicles are there, we have a scope to form the rock. Okay. So these things need to understand. Okay. Like, okay, these are the vesicles. If suppose, okay, these vesicles are filled by the, okay, secondary material, so there will be less chances to get the groundwater. Okay. Yeah. So we must know the rock, their property, their texture and structure. I hope you got the point. Okay. Even in igneous rock, like if we have different kind of rock, you'll find variability in the groundwater occurrence. So that depend on the texture, structure and composition also. Okay. And these are the, okay, common igneous rock. We have, now sedimentary rock. What is sedimentary rock? Sedimentary rocks are derived from the pre-existing rock under the influence of mechanical and chemical process of different atmospheric agents. We know that. And there are 4 processes are involved to form the, sedimentary rock. It starts from the bathering, bathering and erosion. Because this is give a scope to form the sediment. And for sedimentary rock, sediments are required. Okay. And once sediment formed due to bathering, they go under transportation. Okay. Their transportation. So these transportation we can see in river. Okay. You'll find rounded boulder, sand. So it means sediment are under transportation. Okay. And when these reaches in low-lying area, okay, when these reaches in low-lying area, when velocity of media get reduced, their deposition takes place. Okay, their deposition takes place, and after deposition, what happens? These get lithified, and sedimentary rocks are formed. So it means 4 processes are involved to form the sedimentary rock. Okay, yeah, and there are different structures which help us to identify the sedimentary rock. So when these sediments deposition takes place, you'll find layering. So that layered arrangement of the sediment is known as the bedding, and these bedding can be classified into different groups. Like, okay, these are the different beddings, and we have graded bedding also due to gravitative settlement. Okay, larger grains settle in the bottom and finer upward. Okay, so this is graded. This kind of, okay, now in one rock, okay, this kind of variation we are getting. So this kind of variation will affect the groundwater occurrence also. Okay, when there is textural difference in one rock, so there will be difference in groundwater occurrence as well. Okay, there you see, even, okay, in a small scale we are getting here. In bottom, what coarser grain are there, and top we have fine. Okay, so you find variation in groundwater occurrence. Okay, the ripple marks are there. Okay, these are the sedimentary structure which help us to identify the rock. And we know there, okay, mainly 2 types of rocks are there. First is there plastic and non-plastic. Yeah? So if okay, someone asks, okay, in which case you have a scope to get the groundwater more, in case of plastic or non-plastic? Yeah, in which case, like we have plastic rocks form by mechanical process, and non-plastic rocks form chemical precipitation. So both rocks we have. So can you tell me in which case we have a scope to get groundwater more? Plastic. Why? Because in case of plastic, there is a scope for the intergranular space. But in case of non-plastic, very rarely. Okay, because that is more hard and compact, very fine grain. So in that case, I hope you got the answer. Okay, so this kind of knowledge is required to understand the groundwater occurrence. Okay, these are the textural element of the sedimentary rock, and these control groundwater occurrence. And there are different component of sedimentary rocks are there. We know their clasts are there. We have matrix. Clasts are rock or mineral fragment. Matrix where these grains are embedded. Where these grains are embedded. And cementing material bind these matrix and grain. Okay. Yeah. And grain size, vary. Okay. And we have here, these are the range of the grain size. This is given by Wooden Banford. Those who are geologists, they know here. Okay, so we can simplify it like silt and clay we consider as a fine grain sediment, sand as a medium grain, and gravel, pebble, copper, and boulder these as a coarse grain. Yeah, and roundness is how smoother the edges. Okay, and this depend on the rate of transportation. When transportation that sediment travel more, you'll find more rounded grain, no matter their what kind of sediments are there. Okay, so here low sphericity, high sphericity. That roundness means how smoother their surface. Okay, no matter their sphericity is low and high. Yes, these are the this is the actually linkage with the transportation and their roundness. When that sediment travel more, it means you'll find more rounded. Next, sorting. It is very important property for the groundwater occurrence point of view. If we have well sorted rock, well sorted, it means the uniformity in the grain size. Okay, if we have rock specimen, if whatever grains are occurring within the rock, if their size more or less same, so it means that rock is well sorted rock. Okay, and if there is big difference in the grain size, that is known as ill sorted rock. So can you tell me in which case we have more scope to get the groundwater, in case of ill sorted or well sorted? Yeah, because this is also linked with the groundwater. Yeah, so in which case we have a scope for the groundwater occurrence, well sorted or ill sorted? Sorry. So in case of ill sorted, you will get more water. How? Can you justify your explanation? Yeah. How? Okay, it is possible in case of ill sorted rock will get groundwater, more groundwater. Is there how? Like if suppose ill sorted rock are there is big difference in the grain size. So what will happen? Finer grain will occupy the void space, so there will be less porosity, less permeability. So if grain size are same, so there will be less chance to scope the to fill the gap. So always in case of well sorted rock, we have more scope to get the groundwater as compared to ill sorted rock. Okay, fine. Yes. So you see, like we have well sorted and we have ill sorted. In this case, what happened here? You see, all intergranular spaces are filled by fine material. This is ill sorted, and this is the here this is well sorted. So in this case, how that intergranular space will fill? There is no scope. So always in case we found based on study I'm saying and you can see here also in this case we have more scope to get the groundwater. Okay. Yeah. You see here. Yes. And metamorphic rock, these are formed under the influence of high temperature and pressure. So when high in this condition, what happens? Mineral are aligned in a particular direction. Okay. Yes. So these can be classified into different groups based on the temperature and pressure applied there. We have different type of and grade based on the depending on the intensity of temperature and pressure. Okay, I'm not going in detail about these. Yeah, and these are the different metamorphic rock. And question arises, we have these three kind of rock like igneous, sedimentary, and metamorphic. Question arises how we can differentiate one from another. We have to take decision where we'll get groundwater, and through surfacial feature you cannot who are not aware about the geology, geomorphology, they cannot comment on what kind of condition is there regarding groundwater occurrence. But if you are aware about the geology, you can easily interpret. Okay, so first and foremost is required how we can differentiate one rock and another. So if you see, like we have igneous rock. Igneous rocks are very hard and compact, and if you see in grain level or mineral level, you'll find interlocking. Minerals are interlocked. Okay, so that and other case like we have metamorphic also, that is also hard and compact. So with interlocking, in case of metamorphic rock, you'll find alignment in the mineral. So easily we can differentiate one from another like metamorphic and igneous. And in case of sedimentary rock, what you will find? You will find rounded grain, and these grains are embedded in the some fine grain material. So easily we can differentiate one rock from another. Okay. Condition is that we should aware about their texture and structure. Okay. Yeah. And that is the classification of that rocks, okay, based on their origin. And we have hydrogeological classification of rocks also. And all rocks are classified into 4 categories. These rocks are 4 categories based on their porosity and permeability. Okay, property are what? Porosity and permeability. So like we have aquifer. Aquifer are porous and permeable. Both property you will find. Okay, if rock, whatever rock material is there, which are naturally occurring, if they are porous and permeable, that will be considered as an aquifer. And we know aquifer are important for groundwater occurrence point of view. If rock is less porous and less permeable, so that is your, that is known as aquitard. If any rock, okay, having property, that is less porous and less permeable, that will be known as aquitard, and sandy clay is the example. If rock is porous, okay, if rock is porous but impermeable, fluid cannot transmit through that rock. So that is known as your fluid, and clay is the example. Clay is impermeable. Okay, fluid, whatever that water, if you apply there over the clay, fluid cannot transmit through the clay. It will take time, 200. If 1 meter thickness clay, if you take, and if you apply water, it will take 200 years. Okay, so how you see, they are taking time to be considered negligible. Okay, and aquifuse, that rock, if rock is neither porous nor permeable, that is known as your aquifuse. So only we have these 4 categories based on the porosity and permeability. There is no scope for the 5 category. We tried, but there is no scope. You can also try. If you find, let us know that. Yeah. And what is the source of the rock? From where it comes? So there are different sources like metric water, that water which we get through the precipitation. Okay. So what happens? Okay, and we have ponate, magmatic, and metamorphic water. Ponate water is that water which entrapped within the sediment during their formation. Magmatic, water derived from the magmatic activity, and metamorphic from the metamorphic. These also may become source for the groundwater, but their negligible contribution is there. Main source is your metric water, or we can say that water which you get through the precipitation. Okay, so once precipitation takes place, some water go as a runoff. Okay, and some get infiltrate and become part of the groundwater. And if we see any open well, we'll find there are different zones are there. Like we have this is the division of subsurface water. Here we have main saturated zone and unsaturated zone. Unsaturated means pores are partly filled with the water, and saturated means all pores are filled with the water. And this unsaturated zone is further classified into 3 groups. Soil water zone, it is very important for the plant growth. Okay, and wetter zone give scope to infiltrate water and reaches in the saturated zone. And capillary zone is there which developed due to the capillary action. Yeah. If you see any well, here, and question arises, what is the difference between water table and water level? This is very important concept for hydrologists who are working in this area. And water table map is very important to understand the groundwater flow, where groundwater is flowing. Okay, what is the recharge and discharge condition? I have given you one exercise, where we'll prepare the water table map and understand the flow direction, where groundwater is flowing. So here you see this person is measuring water level. If we are measuring water, depth of water from the ground surface, that is known as your water level. if we are measuring with respect to MSL value, whatever mean sea level value are there, with respect to MSL, so that is known as your water table. If you prefer water table, ma'am, we can understand the recharge and discharge condition. If water table are forming this kind of pattern, where value are higher in the center and lower in the periphery, this will indicate that you are in the recharge area, recharge zone. And if value, water table value are low in the center and higher in the periphery, it means you are in the discharge area. Okay, so water table contour can help us to understand the recharge, discharge, okay, even flow also, where groundwater is flowing. So this is very important concept for hydrological point of view. And we know that groundwater occurrence, is depend on the aquifer. So there are different type of aquifers are there, like we have confined, unconfined aquifer, quartz aquifer, semi-confined aquifer. So these depend on the geological setting. What kind of geological setting is there? This is unconfined. It is open to the surface. It directly receive water from the surface. And this is the most common aquifer type. Everywhere you will find. Okay. We have confined aquifer also. If suppose, porous and permeable rock formation is confined by the impermeable layer. That is underlain and overlain by the, impermeable rock. That is known as your confined aquifer. In this case, you see, sandstone is aquifer, porous and permeable. You see, this is sandstone, okay, and this is underlain by cell, and cell comprises clay mineral. Clay is impermeable rock, and this is underlain by sandstone is underlain by cell, impermeable rock, and overlain by the cell. So this is confined, confined, by impermeable rock. So this kind of if geological setting is there, this is known as your confined aquifer. Confined aquifer. So if we dig well in confined aquifer, you will find automatic flow of the without any power. You can automatic flow of that well you will find. Once you tap here well, what you will find there? Artesian well. This is known as your artesian well. So in some cases, when we dig well in some confined condition, what happens? Without any energy, you'll find continuous flow of the well. So this is due to the confined aquifer. And their rise sometimes is very high. Even 10 meter, 20 meter you'll find, and that depend on that pressure. Here, if this physiometric surface is below ground, you will find less rise. If this flow rise is high, you will find high discharge of the groundwater. Yeah, and we have semi-confined also. If overlying whatever layer is there, that is acutard, less porous and less permeable. In that case, there is possible for the exchange of water. So this is known as your semi-confined aquifer. We have parts also. If localized aquifer is there, the main water which is separated from the main water table. If suppose any lanceoid body of clay is there, so this will form localized water table condition. So this is known as a parts water table. So this kind of setting also we get in nature. So this is the and you find fluctuation in the groundwater. If we see pre-monsoon and post-monsoon water level, what we will find? In case of pre-monsoon, groundwater will be lower down because of the heavy discharge. And post-monsoon, after rainfall, what happens? Groundwater get recharged. You will find rise in the water level. So this is known as a fluctuation. Fluctuation. This is known as fluctuation. This kind of things are very common everywhere. Yeah. And when groundwater is available everywhere, we are excessively dependent on the groundwater. Why? Because it's available everywhere, and no matter where you are, you'll find the groundwater, but their occurrence will depend on the hydrological condition. Okay, and it is free from the contamination, and as per our requirement we can withdraw it, and even during drought also we get the groundwater, and that's why we are excessively dependent on the groundwater. And when we are excessively dependent on one resource, what will happen? You'll find some undesired effect, some challenges are emerging, like okay, the depletion of groundwater is going on. If you see in some part of India, like in Indo-Gangetic plains, that depletion is very high, 1 meter per year. Okay, and pollution issue are also arising, like nitrate, chloride, arsenic. These issues are also arising in case of groundwater. And drinking water shortage is there in urban area, not only in urban, even in rural area we are getting. Okay, and in case of coastal aquifer, sea water intrusion is there. So these challenges are emerging, and it is found that 50% of India groundwater wells are showing decline trend. Okay, and more than 100 million people are living where poor quality water is there, and they're suffering from the waterborne disease. Okay, here, and it is observed that surface and groundwater is slowly depleting in India. Okay, so we must understand, okay, their occurrence. So we have different techniques to understand or to assess the groundwater, and remote sensing and GIS, these are one tool. Okay, these are the tool to assess the groundwater. Remote sensing is what? Remote sensing, we get information without coming in the physical contact. So for geological study or for hydrogeological study, we have satellite data. Okay, and GIS is also very effective tools which help us to analyze the spatial based information. And if we are in geology or in mining or civil, okay, these tools are very useful. Okay, so what are the advantages? What are the advantages of these tools? So we have synaptic view. Large area. Okay, large area we can see through the satellite data. Okay, regional feature we can understand, like okay, if regional fault are there, so easily we can delineate using the when we have satellite data, because we have synaptic view. And feasibility, even non-accessible area we can cover. Like in Chhattisgarh, we have Naxalite problem. We cannot go there for the field work or for the geological or hydrological study. So what we can do? We can use satellite data to understand the geological feature or hydrological feature. Time saving, we can cover large area in very short time. Okay, so and even single image we can use for the different purpose. So these are the advantage, but we have limitation also. I told you groundwater is hidden resource. Okay, it occurs below the earth's surface. So directly using remote sensing data we cannot observe where groundwater is occurring and where not occurring. Indirectly we have to infer. So this is the limitation, because remote sensing data cannot penetrate the ground surface. We can understand only surfaces feature. This is the limitation. And nowadays, remote sensing data is freely available. Freely available. We can download. We can use many GIS or softwares are there which are freely available. Like quantum GIS is there. We can freely use that software. Yeah. And if we are going for the hydrological study, there different indicators are there. There are different indicators which help us to understand the groundwater occurrence. Some indicators are there. So these are classified into two groups: direct indicator and indirect indicator, or we can say first order or second order. Direct, if you are getting these indicators in field, okay, so it means we have very good chance to get the groundwater. Okay, very good chance. Like if feature associated with the recharge, like if you are near to any surface water body, always we have get the groundwater. Always near you see that if you are close to any surface water body like river or lake, you'll find good groundwater condition. And when you move away from that water body, you have less chances. Feature associated with the discharge. Okay, like spring. If you are close to spring, those areas we have always scope to get the groundwater. Soil moisture. During summer, okay, if we are getting moisture in the soil, that will also indicate the occurrence of groundwater. Yeah. Vegetation during summer, in some region we are getting vegetation, that will also indicate groundwater. So these are the direct indicators which help us to understand the groundwater. Indirect also, and these are second order. Okay. So these will also help us. Okay, but primary are important. Okay, we'll discuss these how you can understand using the satellite data. Okay, and these data are required for the groundwater study. If these data are available, easily we can comment on the groundwater occurrence. So, like for any remote sensing based study, image selection is very important. Suppose, okay, like if you want to cover, very large area. Okay, so you have to take a small scale, resolution image. If you want to cover, very small area, so you have to take that large scale or okay high resolution image. Okay, this is one thing. An important thing, like okay, if you want to interpret any geological feature, like lineament or any structure, if you are taking post monsoon image, due to the vegetation cover, you will be unable to interpret. Okay, so you have to take pre monsoon satellite data. Like here example you see, in this case, this image belongs to Bundelkhand region, and Bundelkhand is known for the water scarcity. You see, in case of okay, this case, in this case, you see most of the features are covered by the vegetation. This okay, this all some composite color, image. The reddish color is showing vegetation cover. Most of the feature are covered by the vegetation. So feature are not visible. But in case of pre-monsoon, we can see the some structural feature. So this kind of okay image selection is very important. Now coming to the indicator feature which are associated with the recharge zone. So if we are near to water body, we have a scope to get the groundwater. In this case, you see, if we have any river, so in downstream side, what happens? That river become more wider. Okay, due to that tributary. But in this case, what do you see here? In downstream side, the river is thinning. Okay, why it is thinning? Because this river is contributing water to the groundwater. Okay, this river is what? So when you are giving, so you will be in losing condition. So this is not a losing river. Okay, so this kind of feature if available in nature and we are able to interpret using remote sensing data, okay, in this case, always we have a scope to get the groundwater. Always. Okay, this is associated with the recharge zone. Okay, yeah. And what is the gaining and losing river? You see, like if these are the type of river. If river is getting water from the saturated zone or from the groundwater, that is known as your gaining river or affluent river. If river is contributing water to the saturated zone, that is known as your losing river or influent river. These two type of river there, and this river is type of river associated with the groundwater. Okay, associated with the groundwater. So this in this case, what happening here? Here river is contributing water to the saturated zone. That's why in downstream side, what happening? There, thinning. Okay, that becoming more thinner. Okay, yes. So this kind of feature need to interpret using satellite data. Then only we can understand the groundwater. Now feature associated with the discharge zone. Okay, we have natural balance between the recharge and discharge. What do you think? Recharge of groundwater is good or discharge is good? What do you think? Discharge is good or recharge is good? Huh? Yeah. Both are good. Recharge and discharge. Yeah, both are good. Even you see, you go in remote area where no one is there, there is no any anthropogenic influence. What do you think? Their groundwater always rises up. If suppose in any area, if groundwater is rising only and there is no discharge, what will happen? that will reach near to earth surface and will create the, create waterlogging problem, which is the, which will decrease the, with fertility of the land, salinity of soil get decreased. So that big, that is one kind of environmental problem. And nature have balance, natural recharge and discharges there. So even in those areas where anthropogenic influence are there, water level always balance in balance. Okay, don't think there is an imbalance. We are influencing and affecting these natural conditions. So if you're near to that area where some springs are there, discharge, these are the discharge zone, groundwater discharge zone. Like we have recharge, we have discharge. So through a spring, groundwater get discharged. So if you are near to any discharge zone, that always give you scope for the groundwater condition. Okay, so here you see in this case here in southern portion, the drainage formation are more. Why? Because of the springs. Because of the spring. So if you are in this kind of area, you have a scope to get the good groundwater condition. Okay, yeah. Now coming to the soil moisture, if these also we can interpret easily. Okay, if soil having moisture, that will give you darker tone. Okay, darker tone. So in this case also we can understand this moisture, and there is no any surface water body from where it is getting. From where surface moisture is there in the soil. This is due to the good groundwater condition. We have vegetation. If in summer season, if we are getting vegetation, in some zone, it means vegetation required moisture, water for their growth. So that will also indicate you groundwater occurrence. And vegetation can be categorized in two categories. There is one there root. If shallow rooted vegetation is there, that indicate scarcity of the water, dry area. If deep rooted vegetation is there, that will indicate you groundwater occurrence. Shallow groundwater condition. So we have theriotophyte and xerotype. Theriotophyte means deep rooted vegetation. So that will give you indication of groundwater. And if we have xerotype, that will indicate you shallow groundwater condition. Yeah, lithology. We discuss a lot about the lithology. And we know it is very important. But we must aware how we can differentiate one rock from another. So if we are able to easily we can interpret these lithological data using satellite data. And nowadays GSI is providing freely geological data. Yes. Topography map easily we can prepare using digital elevation model. And if we are if suppose we are in the elevated region, we have less chances for the groundwater occurrence as compared to low-lying area. In low-lying area, there is a scope for the more recharge, and always we have a scope to get the groundwater. Landforms, and these landforms can be classified into two groups. Like we have erosional landform and depositional. So in case of always depositional, we have good groundwater condition as compared to erosional landform. Weathering. If you are in the hard rock terrain like granitic rock terrain or any metamorphic rock terrain, there you not find any primary porosity. So we get due to the secondary porosity, and weathering is very important feature which help us to get the groundwater in hard rock terrain. Weathered rock also considered as an aquifer. So like if you are in Deccan Trap area or you are in Bundelkhand region, due to weathering, joint and fracture only we get groundwater. So depth of weathering play very important role if you are in the where in hard rock terrain. These also we can understand. You see here, this is the weathered rock. So this gives scope for the groundwater occurrence. Structure, these also we can interpret. These also we can interpret, and these also control the groundwater occurrence. Lineament, these are the fractured zone. Occur as a spray or curvilinear. And when you are close to these lineament, always we have the scope to get the groundwater. And when you move away, you have less chance to get the groundwater. Okay. Soil type, you know there are different type of soil. Like if we have soil, sandy soil, if we have clay soil, so you'll find big difference in the groundwater accuracy. Always in case of sandy soil, you'll get good groundwater condition as compared to clay soil. Okay. Drainage. Okay, we discussed, drainage, okay, is very important. And if you are in the high drainage density area, you have less chances to get groundwater as compared to low drainage density area. Okay, so if you are in the southern portion, you'll find good groundwater condition as compared to northern portion. Okay, yeah, yeah. And now coming to the one case study here. Yes. Okay. So here actually, we discuss about a different indicator and what data are required for the, hydrogeological study. And we are giving here emphasis to the, we are giving emphasis to the remote sensing and GIS techniques. There are many techniques for the groundwater, assessment purpose. So we are using, remote sensing and GIS techniques here. So here, one case study I'm sharing with you all, which we carried out in this, Kulan water site, which is part of the Raipur district here. And we use, remote sensing and GIS techniques to assess the groundwater. Okay, here. And this is the location of the study area, and we use different data, and data we collected from the different source. And data can be categorized into two main category. Those who are doing research, they know primary and secondary. Primary data which we collect from the we collect by ourselves, and secondary data which we collect from the other source. Okay, so here both kind of data we use, and these all data is freely available. Okay, all data is freely available, and this is a flow chart methodology. For any study, systematic methodology is required. Okay, so we adopted here methodology where we collected data, and based on those data we prepare different thematic layer, and based on the response for their occurrence of groundwater, okay, we assign weightage and rank. Okay, and then we run the weighted overlay analysis, which is available in GIS environment, and we get the groundwater prospect map. Okay, so this simple techniques, okay, to assess the groundwater, to develop the groundwater prospect map. And here, we use land use land cover map, slope map, geology, geomorphology, rainfall, drainage density, lithium, and groundwater level. Okay, I'm expecting from you tell how land use land cover, like we have settlement area and we have cultivated land. Okay, so where we have more scope for the recharge, and and then groundwater occurrence, where like we have different. Based on their response for groundwater recharge and occurrence, we assign weightage. Okay. If you understand this, you can understand the groundwater occurrence and this technique. Like we have slope. If you are in a high gradient area or if you are in low gradient, so always in case of low gradient, we have more recharge scope and thereafter groundwater occurrence. Okay, so we'll discuss these things. Like we have geology. If you are in the hard rock terrain, or in soft rock terrain. So in case of hard rock, we have less chances to get the groundwater as compared to soft rock. Okay, accordingly, weight is assigned to this layer. Okay, for groundwater prospect mapping. We have drainage density also. Okay, here this we can prepare in the GIS environment if we have digital elevation model here. So if you are in the high drainage density area, you have to assign less weightage as when you are in the that high weightage where density is less. Okay. Yes. Land use land cover, like we have different classes of land use land cover here. We have settlement, forest, cultivation. Okay. If you are in the border body, okay. So in that case, you'll find more groundwater. So we have to assign more weightage. If you are in the settlement area, you have to assign less weightage. Okay. Yeah. Slope. If you are in the high slope, in that case we'll assign less weightage. And when you are in the low slope, or low-lying area, you have to assign high weightage. Okay. Here, soil texture, if sandy soil is there or clay soil is there, so according to their response for the groundwater occurrence, you have to assign weightage. Rainfall, if rainfall is more, okay, so it means that will give more scope for the recharge. If rainfall is less, what you will find? Less chances. Okay, but other factor also defined. Like, okay, if rainfall is there over granite, and that is very hard and compact, so is there any scope to get the groundwater or recharge? No. So geology, geomorphology, okay, and other structure also play very important role. For example, in India, okay, where we have more water scarcity in India. Okay, Indian respect, you tell where we have more groundwater or water related issue, where we have water scarcity in India, where in which state? Rajasthan. Why? What is the reason there? No, that is what is the reason? Because the low rainfall is there. You see what is the average rainfall of the Rajasthan? Check now, and you check the average rainfall of the Maharashtra and average rainfall of the UP. Now check, and we'll compare. How this geology is controlling socio-economic condition. What is the average rainfall of Rajasthan? What it is, mm or centimeter? Okay. So it means 640, or 650 average. Okay. What is the average rainfall of Maharashtra? What is the average rainfall of the Maharashtra? Yes. And you tell average rainfall of UP. Of UP. Okay. And what about the Maharashtra? Do you want a simple search? Okay, in Google, you'll find average rainfall. In single click, you'll find. You see, so in case of Maharashtra, we have more rainfall as compared to the UP. Okay, we'll compare only these two states. Okay, that condition of Rajasthan is totally different. Okay, because their economy depend on tourism also. Okay, but UP and Maharashtra, they're totally dependent on the farming. Okay, so you see in which state suicidal attempt are more? In which state suicidal attempt are more? Why? Even they have more rainfall. Actually, there geology is playing role. Geology there, mainly Deccan Trap is there, which is very hard and compact. Even their rainfall is more, but groundwater occurrence is less, and they're dependent on the only rainfall. And when rainfall is there, and a drought condition is there, what did they attempt suicide? Okay, this is the reason, and how geology is controlling socio-economic condition. Okay. Yes. And in case of UP, you see, is there any suicidal attempt of any farmer? No. वो fight करके मर जाएंगे, लेकिन suicide नहीं करेंगे. है ना? So you see, you can do detailed study की how geology and mineral occurrence controlling socio-economic condition of the state or nation. Okay. Okay. Yes. So and we have groundwater level. Okay. तो यहाँ समझ में आया कि rainfall, only rainfall is not enough. Geology, geomorphology is also important. Hope you got the point. Okay. Yes. Yeah. And groundwater level, if shallow groundwater condition are there, it means we have good groundwater, and if deep is there, okay, so we consider that poor groundwater condition. Okay, lineament. Okay, so lineament buffer is prepared here, so when we are close to lineament, we get good groundwater condition, and when we move, their influence is less, and we get less groundwater. Okay, yeah, and we assign weightage and rank to all the layer and the subunit, and we tabulated here. And this rank and weight we assign based on the response for the groundwater accuracy. Okay, yeah, and we run this model in GIS environment, and finally we found the output. Okay, and this model help us to understand the groundwater potential. So in some region we are getting high potential, and some region we are getting low potential. Okay, so this final output is very important. This output is very important because this output can help us to manage and develop the groundwater. Yes. So is there any question? Is there any question? And okay, after this break, we'll do exercise. Okay. This, okay, we have created using GIS software. Okay, I will teach you how manually can do. Okay. How manually you can calculate and assess groundwater potential zone using data which we can develop, okay, which we can acquire very easily. Is there any doubt now? Is there any doubt? Online participants are not giving response.
Okay, all of you, we will again come back after 15 minutes on the same venue. Take your refreshments break and you can take the selfie and easy to करना. Resume the session.
नहीं मैं तो ब्रेकफास्ट करके आया. अच्छा सुनो वो प्रिंट आउट अरेंज कर दो है ना प्रिंट आउट